Right. So today we have to start the grade 11 revision part, right? So according to the paper that I have sent you, right? I hope to start with the physics lesson today, right? Before that, we will get a rough idea that what are the things that we have to discuss, right? And we will go into uh, do the questions, right? MCQ, structured essay, and the essay, right? Based on these parts, okay, right? So, according to the syllabus in grade 11, right? These are the lessons that roughly I mentioned, right? First, I select the physics part, right? So, these are the lessons, right? Waves and optics, the light lesson. Then the next one, the heat lesson, right? Then electricity, and the electromagnetic induction. Right? So these are the lessons, physics lessons that we have to discuss today, right? This is according to the syllabus that the questions based on for the O-level exam, right? And then the chemistry part, right? In the chemistry part, mixtures, mixtures, and the acids and bases, the last lesson of the first part, acid bases. Then the electrochemistry, electrochemistry lesson is there, and the very small lesson, hydrocarbons. Right? So those are the chemistry lessons that we have to discuss. Right? Six chemistry. Right? When we consider the biology section, right? The very first lesson, plant tissues. Then what is the next one? Photosynthesis. Right, we have totally discussed about photosynthesis, right, during the grade 10 also, right? And the systems, the very lengthy lesson that we have to discuss. And the last one, biosphere. Right? So those are the biology lessons that we have to discuss. Right? And this is special footage, right? For the, you know that for the structured first question, most probably, most of the questions are based on this lesson. Right? There are some parts that have removed, right? Never mind. And I hope to do some structured first questions, right? Totally one paper that include with the structured first questions, right? That is mainly based on this lesson, right? We will discuss it after discussing these things and the biology part, right? So roughly, this is what we have to discuss in grade level, right? So after discussing these lessons, uh, all these lessons, right? And after discussing some questions based on these, right? As in grade 10, we can answer some grade 11 papers also, right? Now also that I think that you have already completed the syllabus, right? But never mind, we will remind or we will refresh your memory and we will answer the questions today, right? So this is the rough idea that we have to discuss in according to the grade 11 syllabus, right? I will erase this. Right. So today we are going to start with this part today. According to the paper that I have sent you, the questions based on the these two lessons today, waves and optics, right? Right. So when we move to the lesson waves, right? When we consider the lesson waves, right? Mainly, I'm only roughly we will discuss, right? When we consider the waves, right? Mainly, we can categorize the waves into two types, right? I think you can remember these things today, right? Yes, what are the main two types of waves? Mechanical waves and electromagnetic waves. Mechanical waves and electromagnetic waves, right? So these are the main two types of waves, right? So when we get the main difference between these two, right? We know that mechanical waves, they need a medium for propagation, right? Or they need a medium for propagate. It may be a solid, liquid, or a gaseous medium. But when we consider the electromagnetic waves, there is no need of a medium to propagate, right? So again, when we consider the mechanical waves, there are two types. Yes, or we can say we can divide the or we can categorize the mechanical waves into two types. That is as yes, transverse waves, and the longitudinal waves. Right? Transverse waves and longitudinal waves. Right? So how we categorize these two, or how we can identify separately these two, transverse waves and longitudinal waves, right? Both are mechanical waves, right? And they occur only in a medium. If there is only a medium, transverse waves or the longitudinal waves occur, right? So when we consider the transverse waves, right, we know that these waves appear according to or due to a oscillation in the medium, so, or due to a vibration in the medium, right? So when we consider the transverse waves, right, the particles move, right? If this is the direction of the propagation of the sound wave, right? Particles move perpendicular to the direction of the wave, right? This is the direction of the wave, right? Right? This is the direction of the wave, or in other words, we can say this is the direction that the energy propagates, right? And the particles are moving perpendicular to that one, right? Particles are moving perpendicular to the direction of the wave propagation, right? This is the particles movement, right? Movement of the particles, right? So in transverse waves, particles are moving perpendicular to the direction of the wave propagation, right? So what is the example for this one? Yes, the very common example for the transverse waves, yes, water waves. right? Water wave. So when we consider the longitudinal waves, right? When we get the medium of the propagation, when we get the medium of the vibration, and when we consider the wave propagation, right? Both are parallel to each other. That means, right? The wave, if the wave propagate to this way, right? The particles in the medium, right, oscillate or vibrate to the same direction, right? This is the movement of the particles. Right, so in longitudinal waves, the direction of the wave propagation and the movement of the particles in the medium, right, both are parallel to each other. But here in transverse waves, the movement of the particles is perpendicular to the direction of the wave propagation, right? So what is the example for this one? For the longitudinal waves, yes, sound waves. Right? So when we consider the sound waves, both the wave propagation and the movement of the particles is for the same direction, or we can say parallel to each other. Right? Otherwise, we cannot hear the sounds that produce in the sound sources if the medium move or the particles move perpendicular to the direction of the wave propagation, right? So in the sound waves, both the wave propagation, the direction of the wave propagation and the movement of the particles to the same direction or parallel, right? So this is the difference between the transverse waves and the longitudinal waves. And you have to remember the examples for these two, right? For the transverse water waves and for longitudinal sound waves, right? Right? And then we have to discuss about the transverse waves. There are some important things regarding transverse waves. Right? So as I told you, right, in transverse waves, the wave propagation, the direction of the wave propagation, right, and the movement of the particles in the medium, right, are perpendicular to each other, right? So when we get the displacement, right, if this is the original position, right, this is the position of the particles in the medium, right, and when we get the displacement, right, displacement of the particle movement, right, this is the original place, right, these are the particles, right, so the sound propagate to this direction and the particles are moving perpendicular to the sound propagation, the direction of the propagation, right? So when we get the displacement of the particles, right, they move perpendicular to the sound propagation, right, in this way, right? They move up and down in this way. This is the original position of the particles, right? And this is the distance. Distance from the source, right? The source is there, right? So the particles move up and down, or we can say perpendicular to the wave propagation, right? So when we get the graph like this, right? this graph we draw according to the positions of the particles in the medium, right? So this is the maximum displacement that the particles can move from the original position. How we name this one as the, yes, what is it? Amplitude. Right? Amplitude. That is the highest displacement that the particles move from the original position. Right? And in a graph like this, we can identify these highest positions. Right? These highest positions we name as, yes, as crest. And the lower position to the opposite direction we name as trough. Right? So we say that transverse waves propagate through the crests and troughs. Right? Transverse waves propagate through the crest. This is a crest and this one also a crest. Right? This is a trough and this one also a trough. Right? So transverse waves propagate through the crest and trough. Right? And also when we consider the two particles, when we consider the two particles that have the same motion, right? When we consider this particle here, it tries to move up, right? This one also moving up and this one also moving up, right? Here also same, right? This one also moving up, right? And when it comes to here, from the original position, they are moving down, right? They move to this direction. And when we come here, right, when we come to here, again, this particle, when we consider this particle here, it also tries to move up. And again, here also same, right? So when we consider the particle here in A, and if we name it B here and C, when we and we will put D here, right? So the particle in A and the particle in C, they have the same motion, right? Because these two particles tries to move up, right? So when we consider A and C, they have the same motion, right? And when we consider B and D, they also have the same motion. They start to move downwards, right? So when we consider two particles, two consecutive particles, right? Two consecutive particles that have the same motion. Two consecutive particles that have the same motion, right? The distance between these two we name as the wavelength. Right? We name as the wavelength and we use the symbol lambda. Right? We use the symbol lambda. Right? So the length or the distance between two consecutive particles, you have to use the word two consecutive particles that have the same motion, right? We name it as the wavelength, and we use the symbol lambda, right? Then here also we can get that one, the distance between here B and D, right? They also have the same motion and we can name it as lambda or the wavelength, right? And there is another thing regarding with this graph or regarding with the transverse waves, right? That is frequency. Yes, frequency. What do you mean by frequency? Frequency. And we use the letter simple F, right? We use the letter simple F. Frequency means the number of oscillations or the number of waves that happen during 1 second, during a unit time or during 1 second. Number of waves, so we can say number of oscillations that occur during 1 second. And we measure the frequency using the unit hertz. Right? And there is another thing that comes with here, that is period. And we use the letter capital T. Right? Capital T. Right? That is what? The time taken. Right? Period means time taken to, yes, the time taken by a particle to complete one cycle or one wavelength, right? The time taken for one particle or time taken for a particle to complete one wavelength, or we can say one oscillation, right? Up to here, one oscillation. According to this graph, there are two oscillations, or we can say there are two wavelengths, right? So period means the time taken for a particle to complete one wavelength, right? That is called the period, right? So we can get a relationship by using the frequency and period, right? It is mentioned in your book also. F equals 1 over T, right? F equals 1 over T, right? T means the time taken to complete one wavelength or one oscillation, right? F means the number of waves that can occur during 1 second, right? During 1 second, right? We know that in the motion lesson in grade 10, we learned that the velocity equals, yes, the velocity equals the displacement divided by time, right? Displacement divided by time. So from that one, right? From that one, we can get the relationship in the waves also, right? So according to that one, V equals, we can get, this is the displacement, the wavelength, and the time taken means T, right? To complete one wavelength. That means this distance, lambda, right? It takes the time T, right? This is according to the equation or the definition that we used in motion lesson, right? Speed means, yes, the difference of the displacement divided by the time, right? So we get this equation by according to that motion equation, right? Here, speed equals, this is the displacement, that means lambda, the distance of one wavelength, right? The time taken to complete one wavelength means capital T or the period, right? So from this one, right, instead of 1 over T, right, instead of 1 over T, we can substitute F, right? So we can write this equation V equals F lambda, right? That is how this equation comes. V equals F lambda. V means the speed of the wave and F means the frequency, then lambda means the wavelength, right? We get this equation according to this one, right? Related with the motion, right? So you have to remember this one, right? For the calculations we can use, right? So this is regarding with the transverse waves, right? So these transverse waves, right, we discussed under the mechanical waves, right? At the beginning today, I told you there are two types of waves, transverse waves, so the mechanical waves and the electromagnetic waves, right? All these are regarding with the mechanical waves, and the other part, electromagnetic waves, right? So we discussed that there are many special properties or the special characteristics regarding electromagnetic waves that you have to remember, right? They no need the medium for the propagation of electromagnetic waves. If there is a medium, that is okay, but there is no medium for the, no need of a medium for the propagation, right? And they affected by, the, or we can say they originate by, due to the oscillation of the electric wave and a magnetic wave, electric field and a magnetic field that are perpendicular to each other, right? Due to the oscillation or due to the vibration of a electric field and a magnetic field that are perpendicular to each other, right? And there is no effect for the electromagnetic waves from other electrical fields or the magnetic field, right? And through a vacuum, right? Through a vacuum, the speed of the electromagnetic waves are 3 into 10 to the power 8 meters per second, right? This is only through a vacuum, right? This is only through a vacuum. If there is a medium, this reduce, right? So that is the speed through a vacuum of electromagnetic waves, right? So you have to remember those features or the characteristics regarding electromagnetic waves and the electromagnetic spectrum, right? That is given in the book, right? You have to remember the arrangement of the electromagnetic waves according to the increase of the frequency or increase of the wavelength, right? You have to remember that one. So these are the things regarding with the waves put there, right? Only I remind the basic things, right, regarding waves. Right, and there are some factors given regarding to the sound, right? Characteristics of sound. We know that for the propagation of sound, a medium is needed, and when we consider the speed of sound through solids, liquids, and gases, highest speed we can find in solid medium and liquid less than that, and gaseous mediums less than the liquid mediums, right? So you have to remember that one. And there are 3 factors regarding sound we discuss here, right? Can you remember the 3 factors? Pitch. What is the second one? Loudness. And the quality of sound. Right? Pitch, loudness, and the quality of sound. These are the 3 features or the characteristics of sound, right? Then you have to remember that pitch totally depend on the frequency, right? Pitch depend on the frequency of the sound, right? And the loudness, it depends on the energy, or in other words, we can say amplitude, right? If the energy is high, that means the amplitude also high. We can get 2 waves like this, right? Right here in one, the amplitude is high, right? When we consider these two, these are the amplitudes, right? If the amplitude is high, that means the energy also high, that means the loudness is high, right? So loudness depends on the energy or the amplitude, and the quality of sound that depends on the instrument or the sound source that make the sound, right? So according to the quality of sound, separately we can identify the musical instruments or the sound sources that produce sound. So these are the 3 features or the characteristics of sound: pitch, loudness, and the quality of sound. Pitch depends on the frequency, and the loudness depends on the energy, or we can say the amplitude, and the quality of sound, right? And at the end of this lesson, you are given the musical instruments, right? We know that there are 3 types of musical instruments according to the part they vibrate, right? The musical instruments that produce sound by vibrating strings and by vibrating membranes and by vibrating air columns, right? And you have to remember the examples for these 3 types. Vibrating strings like violin, guitar, and vibrating membranes, all the traditional drums and the modern drums, right? And vibrating air columns, harmonium, flute, trumpet, right? Those, right? So you have to remember the examples. So that is about the wave lesson today, right? If you have missed anything, right? Again, 2 or 3 times go through the lesson, right? Then it is very easy. There are no very complicated calculations in this lesson, right? Only basically the theory part is there, right? So those are the things regarding the wave lesson, right? Then when we consider the optic lesson or the light lesson, right? Right, when we move to the optics, there first we discuss about the mirrors. Mirrors, right? Separately, when we get the plane mirrors, right, from grade 9 also you have learned these things, plane mirrors. How the image form in plane mirrors, what are the features, right? When we consider the features of the images formed by the plane mirrors, they are upright, or we can say erect, and it is virtual, right? We cannot take to a screen, so the images are virtual and same size of the object. Same size of the object. The special feature is we can observe the lateral inversion, right? Lateral inversion. That means left and right side get changed, right? Those are the main features of the images that form by the plane mirrors, right? And here we discuss about the convex mirrors like this, right? Convex mirrors, and the next one, concave mirrors. Convex mirrors and the concave mirrors, and the uses of these two. Convex mirrors mainly we use as side mirrors of vehicles, right? And the concave, right, didn't is used, right? Right, and mainly, right, when we get the images that formed by these two, convex mirrors and concave mirrors, there are more images formed by the concave mirrors according to the place where we position the object, right? In convex mirrors, only one image is formed, you know, right? And in concave mirrors, according to the place we position the object, right? There are different images formed, and you have to know the features of those images, right? So practice to draw these images, right? If you uh, don't get the idea up now, right? Then we discuss about the refraction. Yes, diffraction. When the light goes through two different transparent mediums, right? When the light transport two different transparent mediums, light subjected to bend, right? Light subjected to bend, that is called the diffraction, right? So according to the mediums, right, when we compare the two mediums as according to their density, we name the two mediums, right, as the denser medium and the rare medium. Denser medium and the rare medium, right? So you have to know how light travels from denser to rare and rare to denser medium, or how the refraction occurs, right? right? So when light enters from denser medium to rare medium, from denser medium to dense, right? From dense medium to rare medium, how the light rays behave, right? This is the incident ray, and the angle between the normal and the incident ray we name as the angle of incidence, angle of incidence. So when the light enters from one transparent medium to another transparent medium, and when the light enters from dense to rare medium, what happens today? The refracted ray bends away from the normal. This is the normal, this dotted line, and it bends away from the normal, right? When light enters from dense to rare medium, light bends, the refracted ray bends away from the normal, and this is the angle of refraction, angle of refraction, right? And when light enters from rare medium to the dense medium, this is the angle of incident ray, and this is the angle of incidence. We use the simple I, right? When light enters from rare to dense medium, the refracted ray bends towards the normal, bends towards the normal. And this is the angle of refraction, simple R. Like I will draw it, right? Like this, yeah. Right, when light enters from a rare medium to a dense medium, right? This is the incident ray, and this is the angle of incidence, right? When light enters from rare medium to a dense medium, the refracted ray bends towards the normal, right? And then this is the angle of refraction, angle of refraction, right? So this is how the refraction occurs when light travel from one transparent medium to another transparent medium, right? Light subjected to bend. It may be away from the normal or towards the normal. That is diffraction of light. Reflection is one incidence of light, and refraction means another phenomenon or another incident of light, right? And you have to know the laws of refraction, right? And another thing that relating with this refraction, when light enters from dense medium to rare medium, a special thing happen, right? This happens only when light travels dense to rare, right? Right, this is the normal, right? As I told you, this is the incident ray, right? Incident ray, and this is the angle of incidence today, right? So when we increase the angle of incidence, when we increase the value of the angle of incidence, we know, right, that normally when the light enters from dense to rare, the refracted ray bends away from the normal, So when we increase the angle of incidence in this way, right, in one incident or in one occasion, what happens when the refracted ray bends away from the normal in one position, the refracted ray goes along with the interface that separate the two mediums, right? This happens when we increase the angle of incidence, right? Step by step, when we increase the value of the angle of incidence in one position or in one occasion, right? When we increase the angle of incidence, the refracted ray bends somewhat away from the normal in this way, right? So in one position, when we increase the angle of incidence, the refracted ray goes along with the interface that separate the two mediums, right? In that occasion, this angle of incidence we name as the what? Critical angle, right? Critical angle, and we give the symbol capital C, right? Critical angle means the angle of incidence, right? Angle of incidence when the refracted ray goes along with the interface that separate the two mediums, right? So this is the critical angle incidence, right? So critical angle means the maximum value, right? That can get for the angle of incidence, right? When we increase the angle of incidence, right? Higher than the critical angle. Higher than the critical angle. What happens, Pute? This refracted ray, right? Again enter to the same medium. Again enter to the same medium. When we increase the value of the incidence higher than the, that means when the angle of incidence is higher than the critical angle, right? The value of the angle of incidence is higher than the critical angle. The refracted ray again enter to the same medium. We name this as, yes, total internal reflection. Total internal reflection. Right? This is also regarding with the refraction. Total internal reflection. Right? Total internal reflection happens only if the angle of incidence is larger than the critical angle, right? If the angle of incidence is equal to the critical angle, the refracted ray goes along with this interface, right? That is called the critical angle incidence, right? And if the I or the angle of incidence is higher than the critical angle, total internal reflection occurs, right? In the book, you are given examples or what are the incidents or what are the occasions that we use the total internal reflection. You have to go through like optic fibers, right? So that is about the total internal reflection and the critical angle incidence, right? So that is about the refraction, right? So after the refraction, we move to the lenses. Right, in lenses part also, same as in the mirrors, we discuss about convex lenses and concave lenses. The images formed by convex lenses and the concave lenses. Here also, there are many images formed in convex lenses according to the place where we place the object, right? The images formed by convex lenses and the concave mirrors are same, Pute. Right? If you go through the diagrams, right? If you go through the diagrams, the images formed by concave mirrors and the convex lenses are same, right? Then it is very easy to remember. And the convex mirrors and the concave lenses are same, right? As in convex mirrors, in concave lenses also only one image is formed where we position the object, right? Whether we position the object anywhere, only one image is formed through the concave lenses. Same as convex mirrors. But here in convex lenses, according to the place where we position the object, different images are formed, right? So you have to know what are the positions that the images are formed and also the features of the images, right? So if you don't remember, right, draw again those light diagrams, right? So those are the things, main things that regarding with the optic lesson, right? Right, so we will move to the paper Bude, right? Let's first take the MCQ one. Right? This is the paper Bude, right? This is the paper that I have sent you. Right? We will discuss the answers. Look at the first one. Right? The first question is based on the wave lesson. Right? First one. Note an example for a wave in which the particles of the medium vibrate perpendicular direction of the wave. Right? Note an example. Yes, what is that? Third one, sound waves. In sound waves, both the particles, the movement of the particles and the wave propagation is parallel to each other. We can say along the same direction, right? Look at the second one. 4 adverse effects of the change in the atmosphere are given below, right? 4 adverse effects are given. Out of the above statements, which are the results of ultraviolet rays? What is the adverse effect caused by the ultraviolet rays? Yes, what is the answer, Pute? Answer 3. C. Cause skin cancers. Right? That is the adverse effect of ultraviolet rays. Right? Look at the third one. I told you that you have to remember the electromagnetic spectrum, right? In which response do you get the sequence in the increasing order of the frequency of vibration of electromagnetic waves of ultraviolet rays, X-rays, and visible light and infrared, right? Only when we compare these 4, you have to arrange them according to the order, increase in the frequency, increase in the frequency. First, the infrared comes, then the visible light. After the visible light, ultraviolet rays are there, and then what the X-rays. That is according to increase in the frequency, right? Increase in the frequency. Question number 3, right? Increase in the frequency. So what is the answer, Bhute? First one, infrared, visible light, then ultraviolet, then X-rays, right? Roughly you have to remember, right? In one order, maybe according to increase in the frequency or according to increase in the wavelength. That is to the other direction, right? In one order, you have to remember. It is very easy to remember increase in the frequency, right? Infrared, visible, ultraviolet, then the X-rays are there, right? So the answer is the first one, right? Look at the fourth one. Correct statement regarding the mechanical waves are mechanical waves. Look at A. They are formed as a result of mechanical vibration in a medium. Yes, that is correct. Right. B. They do not need a medium to propagate. No, that is wrong. For the mechanical waves, there should be a medium for the propagation. So B statement is wrong. Look at C. Sound waves are a type of mechanical wave. Sound waves are a type of mechanical wave. Yes, that is correct, right? So A and C are correct. Third answer, A and C, right? Fifth one. String instruments make sounds by vibrating the string. This is not a factor which affect on the pitch, of string instrument, right? There are three factors affect to the frequency, right? Frequency that formed by the string instruments, right? The thickness of the string, yes, thickness of the string that depends, and vibrating length that also affect, and the amount of stretch, yes, that is also affect. The force exerted on the string, no, the force exerted on the string not depends or not affect to the frequency. So the answer is the fourth one. On all the other three, the thickness of the string, the length of the string, and the amount of stretch, right? All these three factors affect to the frequency of the sounds formed by the string instruments, right? Then look at the sixth one, Pute, right? There, a diagram is given, right? And the wavelength has marked 0.6, and you have to correct this one, right? Look at the question. The distance between two successive peaks, that means consecutive points, right? Successive peaks is 0.6 meters, and the frequency is 2.5 hertz. 2.5 hertz. How long does it take for a wave to travel? Correct it as 3 meters, Pute. Otherwise, there is no answer. 3 meters along the spring. 3 meters along the spring. Right? Right? This is the question, right? The wave is given. Question number 6. The wave is given in this way. Right? It is marked as 0.6 meters. That means the lambda, right? And the frequency is given as 2.5 hertz. 2.5 hertz, right? What is the question? How long does it take for a wave to travel 3 meters along the spring? How long? We have to get the time to that, right? So according to these two data given, this is lambda and the frequency is given. So we can find the speed of the wave. V equals F lambda. F 2.5 and the lambda here 0.6. Right? So the speed of this wave is 1.5 meters per second. 1.5 meters per second. That is not the answer. What is the question here is how long does it take for a wave to travel 3 meters? Now we know the speed, right? And the distance is given and we have to find the time, right? Speed equals the distance divided by the time, and we have to get the answer for the time here. Then make the time as the subject, then distance divided by the wave speed. What is the distance here? It is given as 3 meters and the speed is 1.5 meters per second. Then what is the time in seconds? That is 2 seconds. Time taken is 2 seconds to travel 3 meters. Right? What is the answer, Bute? Third one. Right? The answer for the sixth question, third one. Right? Then look at question number 7. Right? When identical coins of 1 rupee and 2 rupee were released from the same height onto the same cement floor in the same manner, right? The reason for the difference of sound produced is both sounds have, right? 1 rupee coin and 2 rupees coin, right? They release from the same height on the same cement floor in the same manner, right? But the sound produced is different. They ask what is the reason for that is different quality of sound. Different quality of sound because the two sound sources are different. 1 rupee coin and 2 rupees coin, right? Different quality of sound. Question number 8. The frequency of a string musical instrument can be increased. Frequency can be increased in a string instrument. Yes, what is the answer? To increase the frequency, we have to decrease the length of vibrating string. First answer. Decrease the length of vibrated string part. Then question number 9. Right, a wave is given. The graph shows the motion of a mechanical wave. Select the answer which shows the symbols of amplitude, wavelength, and frequency. Amplitude. Yes, what is the letter that denote the amplitude here? A, simple A, that is amplitude. And the wavelength, the distance between two consecutive particles that have the same motion. Yes, we can get the wavelength as B. B, right? One wavelength, right? Wavelength. And the frequency. Frequency means the number of oscillations or the number of waves that occur within 1 second. Within 1 second. 1 second is marked here. So within 1 second, right? One wavelength. Number of waves marked here, right? So that letter is F. Amplitude A, wavelength B, and the frequency F. What is the answer? Second one. Second one. Right, question number 10. The astronauts use for their communication is, the astronauts use their, for their communication is, yes, normally they use radio waves. They belong to the electromagnetic waves. They cannot use the sound waves because there is no medium, right? And X-rays we cannot use for the communication. So the answer is the first one, electromagnetic waves. Electromagnetic waves, right? Then look at question number 11. You are given two graphs that is obtained by the cathode ray oscilloscope. We use the instrument cathode ray oscilloscope to get the pattern of the waves that produced due to the sound waves, right? What is the similarity of two graphs obtained from the cathode ray oscilloscope? Yes, look at. According to the data mark, the lambda is same, 0.5 meters, but it is not given as the answers, right? According to the given time, right, in both the graphs, two waves produce, right? Within the given time, two waves produce. That means the frequency is same, right? Frequency is same. So there is no answer as frequency, but the pitch of the two waves. If the frequency is same, that means the pitch also same. So what is the answer? The first one. According to the graph, the frequency is same because in the two graphs, two wavelengths or two oscillations form. Right? So the frequency is same. If the frequency is same, pitch also same. Right? So the answer is the first one. Question number 12. The phenomena which is called transmitting light ray from one medium to another medium. As we discussed, that is refraction. Refraction. Right? Question number 13. The numbers of the answers are not marked today. Right? The incorrect statement regarding two plane mirrors. Incorrect one. Object and the image are equal to each other. Yes, that is correct. Image is laterally inverted. Yes, that one also correct. Image is a real one. No. From the plane mirrors, it forms virtual images. We cannot take the image onto a screen. So the images are virtual in plane mirrors. So the incorrect one is image is a real one. Look at the fourth one. Object distance and the image distance are equal. Yes, that is correct. Right. Then question number 14. Right. Which of the following is the incorrect ray diagram? Incorrect ray diagram. Look at the first one. First one is correct. Right. Where the in convex lenses, if the light rays are coming from the focus, they refracted parallel to the principal axis, right? Look at the third one. In concave lenses, right? If the light rays subjected along the focus, again they refracted parallel to the principal axis, right? And in the fourth one, glass block is there, right? So in two times the refraction occurs, rare medium to denser medium. That means air to glass. Then again, glass to air. That means dense to rare medium, right? So two refractions occur in the fourth one. That is also correct, right? So the incorrect ray diagram is the second one. Right, second one. Question number 15. The question regarding the critical angle incidence, right? The critical angle for two media A and B is 35, right? That means C, the critical angle is 35. Where A is optically rare and B is optically denser. Right, so the light enters from denser to rare medium, B to A, no? Right? Which of the following correctly illustrate the path of the light ray? Here, the angle of incidence is 42, right? The critical angle is 35 and the angle of incidence is 42. I told you, Bude, if the angle of incidence is higher than the critical angle, what happens? Total internal reflection occurs. What is the incidence? Third one, right? Total internal reflection occurs. The answer is the third one. Question number 16. And there's a mistake, right? You have to correct it one. Which of the following statement correctly describes the characteristics of the image formed by an object placed in front of a concave mirror on its focus? On its focus, right? If the object is on the focus in front of a concave mirror, yes, correct the fourth answer in this way. Larger than the object, inverted than real. Right? Inverted than real. So that should be the answer. If we place the object on the focus in front of a concave mirror, normally we say the image formed in the infinity. Right? But the features are larger than the object and inverted than real. Right? So the answer should be the fourth one, larger than the object, inverted real. Then 17. which is a characteristic of the image formed by an object placed at any point opposite a concave lens. Opposite a concave lens. Right? Right? Which is the characteristic of image formed by an object placed at any point opposite the convex lens. Right? Convex lens. Right? You can mark the focal length to the two sides. When you draw the ray diagrams, use the pencil and the ruler, right? So when we keep the object here, right? When we keep the object here, and you can draw the lens line also, right? If we get the parallel ray to the principal axis, we know the refracted ray goes that it is coming from the focus, right? This is one ray that we can use, the parallel ray to the principal axis, right? And we can use another ray that the ray should goes through the object, right? And goes through the center, right? It goes through without refraction, right? So this is the point where the two refracted rays meet with each other, and this is the place where the image is formed here, right? So according to the features given here, look at question number 17, Pute. Right, magnified, the image is magnified. No, it is smaller than the object, right? Real, it is not real, right? It formed in the same direction, right? To get a real image, we keep the screen here, no, in the other side, right? So to get a real image, the image should formed in this side, but here the image is formed in the same side of the object, right? So the image is virtual. We cannot take to a screen, virtual. So the second one also wrong. Inverted. No, it is erect, not upside down, right? The image formed here is erect. So what is the answer? Fourth one. Right, the answer is the fourth one. Look at question number 18. The headlamp of automobile has a concave reflecting surface like this. Right? In order to direct light to a greater distance, the bulb should be placed. Right? The bulb should be placed. If we get the principal axis here, right? What we want to do is, in order to direct light to a greater distance, right? We want to get the light to a greater distance, right? That means in this way, the refracted light rays should go to a greater distance, right? Then what we have, where we have to keep the bulb, right? So here, the bulb comes as the object, right? Then this is the object, light reflect through the concave surface and reflect in this phase, right? So to direct the light to a greater distance, right? Not to cover a larger area, to direct the light to a greater distance, we have to keep the bulb on the focus. On the focus. Right? Second answer. Second answer. Right? Look at question number 19. The common feature of plane mirror, concave mirror, and convex mirror. What is the common feature? Formation of image due to reflection of light. Right? In all these three types of mirrors, images are formed due to the reflection of light. Reflection of light. Right? Look at question number 20. Right? We are given a concave mirror, right? Concave mirror, and the focal length has marked here as 10 centimeters. The diagram shows a candle 15 centimeters away from the concave mirror. Right? Select the characteristics of the image formed. First, we have to draw where the image is formed. Right? The focal length is 10 meters. Right? And the object distance is given as 15 centimeters. That means away from the focus, beyond the focus, right? We will draw the ray diagrams. The light ray that coming parallel to the right, if it coming in this way, this is a concave mirror, right? So they behave as convex lenses, right? They converge or they reflected through the focus. Reflected through the focus. Right? And another ray we have to use. Right? When you draw using the ruler, right? And we can draw the light ray that goes through the focus. The light rays goes through the focus, right? They reflect parallel to the axis, right? So this is the place where the two reflected rays meet, right? So this is the point where the image is formed, right? So what are the features? Right here, we can take to a screen. So the image is real, right? And it is inverted, and the image is larger than the object, magnified. Right? So those are the features of the image. Real, upside down or inverted. Real, upside down. What is the answer? Third one. Yes, third one. Question number 21. Select the correct diagram which shows the critical angle. Which shows the critical angle. What's the answer, Pute? Second one. Second one. Right? Then question number 22. The following is a classroom experiment which is demonstrated the total internal reflection. Right? Total internal reflection. After putting water into a round bottom flask, the laser light rays have been sent from L, X, and A places. L, X, and A places. Which of the following represent the light rays of total internal reflection? Right? Total internal reflection. According to this question, there is no answer, right? To represent the total internal reflection, the letter M should be there because the light should enter to the same medium again, right? So it can be XOM, OLOM. There is no answer like that, right? XOM, OLOM. If the total internal reflection occurs, right, that should be the path of the light ray today, right? Look at question number 23. The following instruments are used in optical science: kaleidoscope, simple microscope, optical fibers, right? We have to select the answer that shows the correct phenomenon used in these three. Kaleidoscope, I think that you can remember the instrument that we make by using three plane mirrors, right? Simple microscope means the hand lens, and the optic fibers. What is the phenomenon used in optic fibers? Total internal reflection, right? So the answer should be the first one or the fourth one, because C should be total internal reflection. So very easily we can ignore the second one and the third one. Total internal reflection, right? And in kaleidoscope, there are three plane mirrors, right? So the reflection occurs. In simple microscope, refraction occurs because there is a convex lens is there. Convex lens in the hand lens, right? So the answer should be the first one: reflection, diffraction, and total internal reflection, right? Then question number 24. In the diagram, A shows two arrows are indicated in a cardboard. As shown in the diagram B, when a water-filled glass is kept in front of it, the direction of one arrow changes, right? What is the principle which can explain this incident? Which can explain this incident? What happens? Only one arrow change the direction. When we keep a glass filled with water, it acts as a convex lens, right? The surface of the glass acts as a convex lens. So according to the distance of the cardboard and the glass, right, an image can form with inverted one. So what is the phenomenon happens, or the incidence happens here is refraction of light, because the glass with water act as a convex lens, right? So the refraction occurs. First answer, refraction of light, right? So those are the answers for the MCQ questions today, right? Then we will move to the structured essay paper, right? Right, this one. Right. Look at the first question. The figure shows the setup which is used to observe an image formed when a lighted candle is kept in front of a biconvex lens, right? Biconvex lens. What is the first part? Can the image be formed on the screen or not? when the lighted candle is moved from focus towards the pole, right? That means when we keep the object between the focus and the pole, right? Can the image be formed on the screen or not? That means they have asked whether the image is real or virtual, right? Real or virtual. That we will see today, right? There's a convex lens, focal point, right? They say that they keep the object in between the pole and the focus, right? Here, right? We will see how the image is formed, right? If it is parallel to the principal axis, it refracted through the focus in this way, right? And we can get the light ray. This is the object, right? The candle. The light ray that goes through the pole, it goes through the same path, right? So according to the two refracted rays, right? Two refracted rays, we can observe they do not meet in this side because the distance between the two refracted ray get increased, right? So we have to protrude the two light rays here. Right? Then we can observe they meet in this side here. So this is the place where the image is formed. Right? So according to this one, can the image be formed on the screen or not? No. The image is virtual when we keep the object between the pole and the focus. Or we can say when we bring the object from focus towards the pole, right? The image formed here is virtual, not a real one, right? Then second one, sketch the ray diagram. You have to draw the diagram in this way. Sketch the ray diagram to show how the image is formed, right? This is the way how the image is formed. Write two characteristics of the image formed in the above diagram. Yes, this is the image formed here. What are the features? It is virtual, right? And erect, right? Erect. And larger than the object, or we can say magnified. Right? These are the features of the image. It is virtual, erect, and magnified, larger than the object. What is the next one? Name a device which has design relevant to the above situation. What is the instrument? Put a simple microscope, or we can say hand lens. In the simple microscope, we get the image only when the object is between the focus and the pole. That is why we focus the hand lens to get a clear image, right? When we move the hand lens, only if it is positioned as the object is between the focus and the pole, we can get a magnified image in this way, right? So this is the incidence where we use in the simple microscope or in the hand lens, right? Simple microscope. Look at part B. Given below is a graphic representation of a longitudinal wave, right? P, Q, R, S, T, U. The letters are given to represent the points, right? In the above wave, which letters show a cycle or an oscillation? One cycle or one oscillation, or we can say one wavelength. Yes, what are the letters denote? P, Q, R, S, T. Up to T. P, Q, R, S, T. P, Q, R, S, T represent one cycle or one oscillation. Mention how the particles move in the above wave motion. If it is a longitudinal wave, particles move parallel to the wave, parallel to the wave. Explain the term wavelength. How we explain it? The length between the two consecutive particles or the two successive particles that have the same motion, The length or the distance between two consecutive particles or two successive particles that have the same motion, right? We can explain it as the wavelength. Then look at part C, Puti. Musical instrument can be classified according to the way it generates sound, right? Classify the musical instruments and write an example for it, right? Musical instrument that produce sounds by vibrating strings, violin, guitar, right? Vibrating air columns, but the harmonium, flute, trumpet, like that. Then vibrating membranes. We can write the examples, all the traditional drums and the modern drums, like the side drum or the bass drum, getabere, akbere, right? Those examples you can give. Then second one, explain the reason why a drum generates loud sound when tapping strong and a sound when tapping slowly. Right? We know the loudness depends on energy. When we tap strong means we give more energy, then the loudness is high. Right? When we tap slowly, we provide only a little energy, little amount of energy, then the loudness is low, right? Because the loudness depends on energy. Look at the second one, Pute, right? The following figure shows an emergency light system in a house, right? Solar panel is there and the electricity produced in the solar panel stored in a battery, right? Then that energy can be used in an emergency, right? What type of wave sunlight is? Sunlight, it belongs or it is in the range of visible light. So it belongs to the electromagnetic waves. Electromagnetic waves. State the symbol of an light emitting diode. Light emitting diode. LED. Light emitting. So the arrows should be away from the diode. LED. Light emitting diode. Light emitting diode. LED. The energy transformation in the above system is given below. We have to complete the blanks, right? Solar energy converts to electrical energy. That is what happened in the solar panel, right? So according to this diagram, that electrical energy again stored in a battery, right? Then electrical energy converts to what, Pute? Chemical energy, right? In the battery, there is chemical energy. Right? When we connect the battery to the LED bulb, again that chemical energy converts to electricity or the electrical energy. Then from the bulb, we get the light energy, solar energy, electrical energy, chemical energy, again electrical energy, then light energy. Fourth one, right? A graphical representation of a wave is given below. Write the amplitude and wavelength. According to the given letters, we have to select what is the letter that represents the amplitude. Yes, amplitude, that is X. Amplitude is X and wavelength, we can get the both letters. Y and Z, both Y and Z represent wavelength. Wavelength Y, O, Z and amplitude X. State the relationship to calculate the speed of a wave. Speed of a wave. V equals F lambda. That is the relationship we use. V equals F lambda. Right? Then look at B. Again, you have to draw a ray diagram. Then one part B. A diagram to draw rays in a concave mirror is given below. Name the positions denoted by the symbols in the diagram. Name the positions denoted by the symbols. P means the pole, Pute, right? We know that. P means the pole and C means the center of the curvature, and F is the focal point. F is the focal point. There only you have to name, right? In the second one, we have to get the position of the image, right? Here you are given a concave mirror, right? Concave mirror. If C and the object is beyond C. Object is here. It's the place of the object, right? So we have to get the position of the image, right? We take the light ray that is parallel, right? If the light ray comes parallel to the axis, it goes through the focus. That is one, right? And we can use the light ray here, draw the mirror line, right? And we can get the light ray that goes through the C, the curvature. Right? If the light rays goes through the C, they reflect along the same path, right? So this is the place where the image is formed, right? In a concave mirror, when we position the object beyond C, the image is formed between F and C in this way, right? It is not asked, but when we write the features of the image, it is real, right? We can take to a screen, real and inverted, upside down. Inverted, and the image is smaller than the object, right? Smaller than the object, or we can say diminished, right? And the image formed between the place between F and C. Image formed between F and C, right? It is real, inverted, smaller than the object or diminished, and the image formed between F and C. Right? Those are the features of the image. When we keep the object beyond C. Right? Then look at question number 3, Pute. Again, you have to practice to draw a ray diagram. The pole of a curved mirror is named as P, right? And the center of the curvature as C in the following diagram. This curved mirror is belong to which type? What is this one? A concave mirror. Concave mirror, as in this one, concave mirror. If the distance P and C, that means the distance to the center of the curvature is 20 centimeters. What is the focal length? The half of that, that is 10 centimeters, right? C is twice as the focal length, right? 10 centimeters. If the distance to C is 20 centimeters, the focal length is 10 centimeters, right? As shown in the diagram, if the object is placed 15 from P, draw a diagram to show the location of the image, right? We will draw. That is also a concave mirror, right? Concave mirror. Third one, third part, right? Question number 3, third part. Which is the focal length and the curvature, right? Focal length is 10 centimeters and up to C, that is 20 centimeters. So the object placed 15 centimeters from the P, right? This is P now, pole, right? 15 centimeters means here, between F and C object, right? So we can get the light ray parallel to the axis, then it goes through the focus, right? And when we draw the mirror line, right, we can get the light ray that coming through the C, right? Then it goes through the same path. Right, it should go through C and also through the object, right? In this way, right? Right, so this is the place where the two reflected rays meet, right? So this is the place where the image is formed, right? If we keep the object between F and C, image is formed beyond C in this way, right?
Excuse me, teacher.
Yes.
There is a small question, like when we are drawing the ray diagrams in the paper for these kind of ray diagrams, the lines, the point where the lines intersect, it takes a long distance. So it is, what should we do, like if there is not enough space in the given blank?
Yes, Bhuti, right? As in this way, right? So that when we draw the ray diagrams in that way, right? If you are given the distances as here, right? 10 centimeters, 20 centimeters like that, then you can take the distances according to a scale, Pute, right? Otherwise, as you said, the space is not enough, right? So you can get the distances according to a scale, then you can get the position of the image, right?
No, teacher, what I said was that even we take a smaller scale, for example, here I took somewhere around 2 centimeters for the distance between the lens and the focal point, and another 2 centimeters for the focal point and the center of the curvature. So it is a small scale, but when you draw the ray diagram, the lines, the point where the lines intersect, it is somewhere like 10 centimeters away. So like that problem happens. So are we allowed to like just continue it and not like randomly mark somewhere, or do we have to show the line point that it intersects?
No, yeah, that you can show in that way, right? The if you take the scale also, if the space is not enough, right? You can show the images formed in this way, or the normally you get the paper in this way, no, right? Then you can take the paper in the landscape, right? It is better to draw in this way, right? You can mention the images formed there, but we don't know whether they give marks or not, right? So it is better because you are provided enough papers, right? Enough sheets to write the answers. Then it is better to take a separate paper, right? Take a separate paper, put the question number, and draw in the landscape, right?
Okay, thank you.
Right. So here, right, as the fourth one, we have asked the features of the image, right? So this is the image. Supply following information regarding the image, right? Size, right? What you can say about the size? It is larger, right? Larger than the object, or we can say magnified. Magnified. Then upright or inverted. Upright or inverted nature. Here the image is inverted. Inverted, right? Real or virtual nature, right? Image is formed here. Then when we keep a screen, we can take the image onto a screen. So it is a real image. So these are the features of the image, right? It is larger than the object, or we can say magnified and inverted and real, right? Then we will move to the next part today, that is regarding the waves. When speaking with a mobile phone, the sound of it can be heard with another mobile phone, right? Part A. When the person A speaks with his mobile phone, as which type of wave the message travels to P mobile phone, right? Now, what is the type that the message or the wave travel from one mobile phone to another mobile phone? Yes, that is as the electromagnetic waves, as the electromagnetic waves. Second one, what is the type of mechanical wave that transmit between the mobile phone and the ear to the receiver? Now, when we when we hear to the mobile phone, right? When we hear to the mobile phone, how the waves, that means the sound waves, no, sound waves come from the mobile phone to our ear. Those are sound waves, then they should be transfer. So we can say mechanical waves, right? Sound waves, that means mechanical waves, right? Between which places out of A, M, B? A, M, and B, the energy was transmitted without using of a medium. Without using of a medium, that should be the electromagnetic part. That means from A to M. A to M, without a medium also, the waves can propagate. But to hear the sound from the mobile phone, there should be a medium, because from the mobile phone it comes the sound waves, right? So M to B, right? M to B, there should be a medium. A to M, no need of a medium, right? So those are the answers for the structured paper, Pute, right? I think that you get a clear idea. Any question? Right? So we can wind up the lesson, right? If you have any question, Pute, right, regarding the drawing of the image diagrams, the wave lesson is okay, I think, right? Only you have to go through the theory part. If there are any question regarding the drawing of the wave diagrams, right, send me a message, right? Then we will wind up the session today, right? Then have a nice day.
Thank you, teacher. Bye.
Welcome.